switched the homework and quiz to do tonight. So if you have any remaining questions, comments, concerns about those, we can spend as much time today talking about them as we need. There are a couple of quirks about these questions that I didn't realize until yesterday, and I'd like to at least discuss them with you guys to make sure that everyone has all the information they need to make it as fair as possible. And next week, starting Tuesday and running through the end of Friday, the test will be available. So we can spend Tuesday reviewing, and then we can spend all week reviewing if we need to. And then take it during the week. No labs though, free up some time. And to help with studying, I put on the Brightspace page, Brightspace will log back in. On the Brightspace page, I have added there's two files for each, because one's a PDF and one's a Word document, cover all bases. We have a list of practice questions for you, completely optional, but good new questions that you can use to study with if you want. And I'll be uploading an answer key for these soon, like I did for the last test. Additionally, we have the list of topics for all of electricity and magnetism, which includes their corresponding formulas. If you wanted to, you can even use this as a formula sheet on the test itself. So this is at your disposal. Study to help with the formulas. Today, we can look at any remaining issues from the most recent homework, and also talk about the test itself, whatever you guys need before we break for the weekend. So my mouse remembers how to work. So, before we get started, how do you guys feel? And do you need anything specific before we begin?
Okay, I think I wrote this formula wrong. And that's why I kept getting the formula wrong yesterday. So like, okay, you know how F equals Q and then B perpendicular B?
Mm-hmm.
Right? And then that equals MB squared over R?
Right.
And then when you put them together, your V is no longer squared.
Okay, so thank you. That's one of the questions, that's one of the issues with the homework that I need to call attention to. And I like to formally apologize for kind of all the problems that have been going on with this particular assignment. I didn't check it as thoroughly as I should have before I posted it. I had to switch questions out. The questions that were still in there are pretty problematic because of web design reasons. And I feel bad for giving you a bad assignment, and I apologize. The test will be done over web design, but I'm going to be spending the weekend hand building it myself on this particular platform and making sure everything works and that none of the questions have a weird misprogrammed catch-22s in them, because several of these questions from WebAssigned's angle just get things wrong. And this is the question you just asked is actually one of them. WebAssigned is the problem with this one. But I apologize. It should be better than this, and I'm sorry. So there's two specific questions on the homework. We have number 2 and we have number 6 that both involve the magnetic force on a charged particle acting as a centripetal force. And we discussed that formula before. It's a combination of force magnetic acting on a charged particle moving perpendicularly through a magnetic field, and also combined with centrifugal force. These formulas have been combined in the notes into the form radius equals, I'm just going to put the notes up because I'm doubting everything in my brain at the moment. The particle enters the field because its velocity changes due to the force. That means the direction of force is going to change. So sometimes you end up moving in circles. And by combining these two formulas, we have this equation which tells us the radius of that circle. And questions 2 and question 6 require you to use this formula. Except whoever coded WebAssign put the formula in wrong
Okay.
when it generated its answers.
Okay. I didn't know if I was wrong.
You did everything right. If you got the answer that WebAssign wanted by not taking the square root, then your math was right. It's technically you're supposed to take that square root, but WebAssign had an aneurysm.
But like, I get why it wouldn't be squared, as in like when you combine, you also have a b, right? So it's like you equal them to each other. Like, if, you know what I'm saying? But I did notice that the notes did have it squared, so I didn't know.
My whole world just got turned upside down. One second. I'm checking a source outside of my own notes and outside of WebAssign, and you're actually correct. When you combine these formulas, that QBB equals mv squared over r. If you're solving for r equals mv squared over QEB, you can get some there. So the notes I've been giving you are what's wrong. And now I feel worse for 10 million reasons. Well, I need to go hand in my physics degree. See you guys. Dr. Whitaker's not here. I can't hand in my degree yet. Okay. So that means, at least in that specific regard, WebAssign isn't broken, because for number 6 and number 2, you needed to use the version of the formula that didn't have the square in it, which is technically the correct one. So I need to fix that for future generations before I accidentally reteach the same notes next year without thinking about it. Okay. Oh, it's better in my notes now. Okay. So, announcement then. This one's not a problem with WebAssign, it's a problem with the notes. That is the version of the formula that you actually need. And I probably need to adjust the study sheet that I put on Brightspace now. Yep, squared is on there too. Excuse me while I scream internally for a second. Okay, we're good. Okay, so announcement one. That's the correct version of the formula. Please indicate that on all possible sources where you might see that particular formula. And please accept my, fourth apology for today. Different thing to be aware of when working the homework and the quiz. This probably comes more into play with the way one of the quiz questions is worded. Most scientific publications will specify, with a little image in the corner, where all of their axes are. We assume this is positive x, we assume this is positive y, and if z is relevant, they will try to specify before they do anything else which direction z is. Me, in all of my notes, has been operating under the assumption that the positive z-axis points out of the board if this is y and this is x. WebAssign doesn't agree with me. They don't say this anywhere. Like, there's no little flag up in the corner of the question saying that WebAssign considers z to point into the board. Sorry, positive z to point into the board. But based on the questions and how the answers are panning out for a couple things on the homework and quiz, this is the assumption WebAssign makes.
Wait, I did the assumption that we do, and I did get it right, so I don't know.
Oh.
Wait, because we said positive z is out of the board, right? Because that's what we had like in the right-hand rule notes.
Correct. That is what I have been. That is how I have been doing it. How a lot of people I know do it.
Well, that's how I did it, and I mean I did get it right, so I don't know.
Did you take the quiz already?
Yeah.
Interesting. So you did the quiz and you got question one completely correct?
Or maybe I did it wrong, I don't know. Like,
Based on the way that I'm doing it now, if you do right-hand rules, one of the answers is definitively telling me it should point that way, but WebAssign calls that negative z. So keep this in the corner of your notes when doing WebAssign questions. There's one in particular on the quiz where this becomes very relevant.
are you talking about one or two?
One. I suppose two is wrong.
I can't pull it up anymore, or can I?
I am not sure. I have not accessed it from the student side. Okay. I'll probably be sending out an email over the weekend with some just various announcements and instructions. A lot of the same stuff I've already told you, so there might not be anything new in it. But in that email, I'm going to be explaining how the formula in the notes was incorrect, and I'm going to be sending out a new formula sheet with that information. So when that email arrives, that's one thing that will be it.
Oh, yeah. I think I can only see it once. Like it's due.
Yeah. Okay. Is there any other specific questions you guys have about the homework or possibly the quiz?
Wait, can you just clarify your picture again? So we said that the Z, that arrow means it's pointing which one?
Into the board.
And then like, how would they do out of the board?
Based on this wonky 3D perspective, it would look more like this. And some sources might further specify that all of these axes are perpendicular from one another. They added boxes like this. It gets really weird in 3D, but they're all supposed to be perpendicular to one another.
Like, that's website.
Yes, this is what website makes.
And what do we do?
So, the assumption that I and most people, I believe, operate under is if that's positive X and that's positive Y, and you set up your hand such that you're pointing positive X and positive Y, the answer should point in the positive Z. So I just have been operating the assumption that this is the positive Z direction. Although I suppose I will not feel that way. It might be basing it on holding your hand like this. This is one of the things with physics. Humans invented it. We didn't invent the universe. We didn't invent all the stuff that we're studying, but physics itself, defined as the study of the universe, is a human-invented thing. Because the universe wasn't studying itself, we are the ones studying it. All of the physics notes we've written down were conceived and written and tested, retested, and rewritten by humans. So they're all inherently flawed and at times subject to interpretation. This appears to be one of those interpretations. The difference between the logic of man and machine, perhaps. Anything else about this particular assignment? Okay. Pardon me. Apparently, internally freaking out makes me even more dehydrated. So, that's every new piece of information, every new assignment before the next test. The study information for the next test is on Brightspace, although I need to go ahead and amend that one formula. I'm just taking a second to reorganize and recalibrate on this sheet. sheet and bright space, and we can rest for a sec. We'll look at the test review information together briefly when I'm done. So if you have any questions, go ahead and ponder those. If not, please do relax. Okay. The topic sheets on bright space have been fixed. No more incorrect formula. So, let's just take a look at this together to remind ourselves what will be on this thing next week. This will be on every electricity magnetism unit, which has been really the last 4, 5. My numbering and ordering here is based closer to the book than based on what we actually did and labeled it as we were going. So if you were comparing in the book, this is where all the information would be in the textbook. Although, the order we went in, we called it 15, 16, and then when we did 17, I also included all of this information from what the book calls Chapter 18, because it had to do with resistors, and it made more sense to talk about it all with the resistors. So we kind of combined 17 and 18 together, which is why the assignment for that week was called Chapter 17.1. They're listed separately here, but it's all still the same related things about circuits and resistors. And then everything listed under Chapter 19 here is all of the magnet stuff we've been doing the past week or two. So 3 chapters about electricity, and then 1 chapter about magnetism with some electricity. This is everything that we've covered since the last test. So, Chapter 15, basics of particles themselves. You know what? We didn't actually talk too much about these 2 little points here, so don't worry about those. The main things to be concerned about from Chapter 15 were the 3 particles. Their masses and charges are known constants, so you don't need to memorize them, but it's good to keep in your head a general sense of scale, positive versus negative, which one's the largest versus smallest. And the formulas we have are Coulomb's law and the combined myriad formulas for electric field. Chapter 16, we started looking at E fields in more depth along with capacitors. Within an electric field, a charged particle is going to move from high potential to low potential, so its potential energy will change based on the distance it moves. This is also summarized in the concept of voltage. Voltage is the potential that drives electricity and electrons through the circuits. The devices that capitalize on this are called capacitors, And you can wire capacitors up in circuits. Remember the two different ways that they add up depending on what type of circuit you have. They work in complete opposite to how resistors work. Speaking of resistors, in chapter 17 started talking about resistor circuits. Electric current is the flow of charge per time. Ohm's law talks about how every piece of the circuit interacts, V equal IR. Talks about resistance as a concept and how an object's resistance is determined. It depends on what it's made of, its temperature, its length, and its cross-sectional surface area. And circuits use up power based on how much energy they're chewing through, based on the current and voltage and resistance of that particular part of the circuit. Then, more information about circuits themselves. In terms of types of things you will, types of questions you will see when looking at circuits, A, be able to tell a series in parallel apart, B, be able to find the total resistance of said types of circuits, C, be able to determine the current through and the voltage drop across the whole circuit, but also individual resistors within the circuit as well. So that entry is referring to how current, every single resistor in series gets the same current and different voltage drop, but in parallel they get the same voltage drop and different current. Be familiar with that and how to use V equals IR to get those pieces of information. There will be combo circuits present, so you will need to do the puzzle solving element of finding the total resistance of one tangled mess of resistors. I'm not favoring the idea of having you figure out the current and voltage through every single resistor in a large combo circuit. So be familiar with the rules for voltage and current in series and parallel, based primarily on pure circuits of those types, because doing a combo circuit like that will take one metric eternity. And I don't want you guys to spend all day on one question.
It's been 5 hours.
Well, it's meant to take you 1 hour. The 5 hours is just doing it online allotment and also academic accommodations. So if you can't do it in 1 hour, it's not fair. If I can't do it in 5 minutes tops, it's not fair. No, sorry. Each question needs to take me. The guideline we like to use is I need to be able to do it about at least twice as fast as you guys. Because I wrote the question because I know what I'm doing. I just look at it, I do it, it's done. Ideally, it should take me like 1 minute, which should take you guys about 10 minutes. And that's what I use when I'm building these things. And the hardest part of the big combo circuits is just, there's a lot of elements that you need to track and write down every single thing, so it takes up a lot of paper and a lot of time just in thinking and writing, not even just physics solving. So I don't find those very fair in a constrained time environment. But you will need to find resistance of combo circuits, so do keep that in mind. Then, last shown here is magnetic fields. We kind of combined the book's 3 magnetic field chapters together into one. So most of it was chapter 19, so I kept that label for what the book says. Remember what a magnetic field is, the 2 formulas for magnetic force on moving charged particles, right-hand rules, torque on a loop that is exposed to a magnetic field. I can probably simplify this further just to say you only really care about the first part there, the part that was in the box on the slide. But in case the web assignment, I'm not planning on web assignment asking you about this specific constant that this formula likes apparently, but if it comes up, I want it to be available to you. The case where magnetic force acts as a centripetal force and the particle starts moving in a circle, I have gotten rid of that squared. And this last piece here, I'm not planning on being the most important, but I'm gonna try to zoom in because I know the resolution's bad. These formulas refer to the magnetic fields produced by things when you run current through them. Of these three, we've only really used this one. This is the magnetic field produced by a single wire when you run current through it. We've done examples using this formula. These two are the same formula, but instead of for a straight wire, they're for circles.
Is the second one, I'm sorry, the loop one, is that one loop?
Yes, one wire ring.
So the first one is just like a straight wire.
Correct.
Second one is a one wire loop, and then the third one is the coil.
Correct. Notice these two are identical, except there's a multiplier for number of coils. So, single straight line, one hoop, several hoops. And the constant in all of them is written here as well. If I further amend this sheet, I might include like the proton and electron masses and charges as further constants. That is a lot of individual pieces, but keep in mind on the tests, certain pieces will be combined, like three topics, three formulas combined into single questions. Expect about 10 questions as before, 110 points total. So there will be bonus points if you get more than 100 points of the 110. And it'll be set to not auto grade. I will email you your score and then change one of the science things accordingly. And practice questions.
But can I ask quickly about, so chapter 19, the formula with the L, right, the F equals I, B, L?
Yes.
Okay, like what is the L, the length of what?
The length of wire that is currently exposed to magnetic field.
So like, you know on that homework problem where it didn't really tell you, but it told you that the force was like Newton per meter, and then we assumed it was 1 meter?
Yes.
So like, unless they give you a length, you use whatever the unit goes with like your force, like that? 'Cause I guess it could have been like Newton per 2 meter, you know what I mean, like that?
Sorry. It could have, yes. So I don't especially like when the question tells you like mass per length or the force per length, but WebAssign just has a bunch of those and they're hard to reprogram out of the question. So in general, the normal bog standard case is you have a wire, maybe you are, maybe you aren't running current through it, and you expose it to magnetic field. The L represents the physical length where they overlap, because only the part where the field touches the wire is there actually going to be any force involved. Hypothetically, if the field encompassed more of the wire, there'd be more field touching it, there should be more force. So the L term is here sort of as a multiplier. The more wire is in the field, the more force you end up getting. Subsequently, the more field there is acting on the wire, and the more wire it encompasses, the more force you get.
Oh, that's why they do that weird unit, right? Because they're like related in that way. Like the more field, the more force.
Which weird unit? You are right.
The
Which
Newton
weird unit?
meter?
Oh.
Newton per meter?
Newton's times meters is just the measure for torque.
No, the Newton per meter.
Oh. Yes. That's telling you if there's, if there's 1 meter of wire exposed to field, there'd be 10 newtons of force on it. If 2 meters of wire exposed to field, there'd be 20 newtons of force. Any other questions about content and such? Okay. Bless you. Darn, I just had a point I was going to make. Where did it go? Okay, so we will also reconvene next Tuesday before the test actually goes open, so that if you have any questions studying over the weekend, you can ask them then. We can further clarify anything we need to. Next week, during the lecture, will primarily be focused on review, but when we hit points in lecture where students are here and there isn't necessarily any electricity and magnetism study questions, I'm going to begin segueing into the final chapter, which is just a brief cursory glance at sound and light. I'm not going to assign anything during next week because there's tests. I'm planning one small sound and light homework assignment the last week of class, which is the last week of April. There will also be the lab that week, and then there's the test itself. Those together will be the last 3 assignments of the term before the exam.
We've been swearing 3 tests?
No. We have 2 normal tests, and there will be the final. So this is the second of the 2 normal tests.
Just talking about like things that we have left. We have the lab, the test, and the things.
Yes. There's this test we're about to do. There'll be 1 more short homework assignment and 1 more normal lab.
Wait, did you find out about the exam time? Like if we could take it?
Teachers are allowed a lot more freedom with how things work these days, other than the school saying that, we're open on Sunday, get used to it. So, for the benefit of all of us, I'm going to kind of run the exam similar to the test itself. But I will just make sure that I'm available. I think I might set it up to where students have to tell me when they're taking it so that I know ahead of time I need to be available and I have to be here for questions. They just have a Google call thing that I can be sitting in and people can drop in and out of. All right. So all that said, if you guys don't have anything specifically wondering about at the moment, we can probably break here for today. We can return to talk about any study and practice questions and concerns you have on Tuesday, and next week will be test week. How do you guys feel?
Oh, can you pull up this list on your end?
Yes.
I want to see how it's being weird.
Scores. It's saying you got a 100.
Oh, no, yeah. But just the problem, I just want to look at it because I don't know if I was like doing the thing wrong. Okay, so positive X, direction. Oh wait, the magnetic field is, wait, what? Okay, so positive Y direction, magnetic field is positive X. Into the board is negative, yeah.
Hang on. Can
Wait.
you tell me how you did that?
Wait, so you're moving in the positive Y.
No.
Wait, because it says find the direction that.
Oh!
Yeah.
Your proton
Well,
is
these are the
here.
velocities. Yeah. Okay.
Maybe while I internally scream again.
No, you're good.
No, it just means I told them the reverse of what it is.
No, yeah, I felt like I was like, oh, because I got it confused, but then I was like, oh, it's talking about velocity.
I was saying the magnetic